And we're back. It's time to sort it out with Mr. Swartout. Here we have a block and a compressed spring, and it's going to be projected by the spring and then slide across a frictional surface until it comes to a stop. So we want to figure out how far it will travel before coming to a stop and what's the time that is required for it to do that. So let's go ahead and split this motion up into two sections, section 1 and section 2. During section 1, the spring is going to be released and then decompress, and then it's going to push the block to the right, and the block is going to gain speed until it reaches this section when the spring is fully extended and it's no longer applying a force. So during that section, we can think about we have spring potential energy stored in the spring. Then all of that energy is going to be converted into kinetic energy of the block at the end of section 1. So we can actually set these two equal to each other. Let's plug in what we know about each of those. Then we can simplify a little bit. Notice that 1/2 cancels out, and then let's rearrange for the speed. So this will be the velocity of the block as it is leaving the spring. Then let's think about section 2. We have an initial velocity for the block, which we just found in the last step. Then it's going to be encountering the force of friction. That's going to be opposing the motion and then slowing it down. So remember this kinematics formula? Let's use that one. Let's figure out the acceleration. Now it's going to be the net force divided by the mass. The net force here is just friction. No other forces acting on it. So friction being mu times the normal force. Then notice that the mass actually cancels here, and this would give us the acceleration of the block based on just the friction force. Now remember, if the block is traveling right, the acceleration would have to be left. So when we go ahead and put it into that formula, notice that's why we have a minus mu times g. Then rearrange for the time, and that should be an expression for the time. Then once we know that, it's a matter of picking the right kinematics formula. How about this one? Because we know that it's accelerating, this is the horizontal distance. We know its initial velocity. It should be what we found up here. Then the final velocity would be 0, and then the time will be what we find in this step. So that will go ahead and give us the distance. So this one, we did kind of have to connect up with kinematics because they asked us for the time. If they wanted to know just the distance, we could have used the work energy theorem for this. Say, okay, the block's kinetic energy to start right here is going to have to decrease to 0. So the work done by friction would need to decrease that to 0 so we could find the friction force, and then we could find the distance that it would take to do that. But this one, because we need the time and the distance, we use kinematics. So that's what you need for that one.